All right, so today we're taking a look at some theory questions with weak acids. So this is part of the equilibrium acids and base section of Chemistry 30, and we are looking at all old diploma questions. So the first question I wanted to take a look at has to do with a picture describing what's going on, and you do see this quite often with the diploma, where it's important that we can interpret the ions in solution within the picture. So in this question, it says that we have a beaker, and which one would best represent a buffer solution if HA is a weak acid. So if you have a buffer is always your weak acid and its conjugate base. So we also need it's the weak base of it. So if HA is the weak acid and this hydrogen gets donated, then H negative would be A negative would be our weak base. So our acid with its conjugate base to make the system. Now when we come over to the beakers, beaker 1 only has the weak acid, so that's not a buffer. Beaker 2 has hydronium and the negative ion. That's not going to work because to be a buffer, you need a weak acid. Hydronium implies there's a strong acid. So not that one. Beaker 3, we have what we need, and in equal amounts, we have the HA, the weak acid present, and we have its conjugate base. And the same thing's happening in the last one. So our best answer here is Beaker 3 and 4, so that would be D. This next one has to do with understanding pHs. So you have some information about rainwater becoming acidic, and it tells you because of the CO2 involved, and there is a reaction there that we could take a look at. But it also talks about the pollutants NO, and I believe this was supposed to be a 2 here, and SO2 from our industry. Now, even though they have that information, it really won't matter when it comes down to the question, because it does tell you in this question, if each component is of equal concentration, then which of them would have the lowest pH? So remember with pH, you're going from 0 to 14. So if you want a low pH, you want to be closer to 0 to be more acidic. And for that to happen, you have to be a stronger acid. So we would take a look at these options here, and we want to just see which one is the strongest. So HNO3, want to look at where that is placed. Right here, that one's pretty strong. HNO2, I am not seeing it at the moment, so I just probably didn't get it in my screenshot, and it'll probably be lower down. H2SO3 is right here, and then you have H2SO4. So between the acids that we can see on this chart, the sulfuric acid is the strongest one, so it would have the lowest pH. Moving on to the next one, at equilibrium, what would be favored? We want the one where products are favored. So if products are favored, then your acid is higher on the list than your base. So with this, and I know it's very hard to see, but for instance, if I was looking at A, I only start with my reactants. Products just help us see what's happening. But you have NH4 positive. So again, I know it's hard to see, but that would be the acid. And then you have H2PO4 negative. So hopefully you can see this as well. So that does occur here as an acid, but it's also going to occur as a base. And I just feel like I can't, H2, there it is. So in this one, your base is higher than your acid. So here, reactants would be favored. So it's not going to be this one. So we're going to check the next one, HCN. So HCN is right here, and it's reacting with HS negative, and that is here. So again, reactants are favored because the base is higher up than the acid. Looking at the next one, HCO3 negative, that does appear on both sides of the chart. So I think I'm going to start to look for the PO4 3 negative. So PO4, you probably will find it before me, is right here. And then the HCO3 negative is right here. So here, your acid is higher up than your base, so products would be favored. We can double check the last one, but most likely, if the answer is C, we would see what we needed to. So let's take a look there. So we have HSO4 negative and HSO4 and HSO3 right above it. And so the base is still higher than the acid, so reactants are favored. So your answer is definitely C here. So I hope that helps, just having that understanding of strong and weak acids in the context of some old questions. If you found this helpful, please give me a like and subscribe to this video, and thank you for watching.